Let's start with the algorithm. So the way we're going to do it, we have built our concept, right? We needed two concepts to understand merge sort, which we have spoken about. Then we also understood that merge sort actually is based on the concept of divide and conquer, so which tells you that we are going to divide the main problem into smaller sub problems, solve the problem for smaller sub problems, and then use the solutions of smaller sub problems to actually find the answer to the main question. So here the problem we are solving is we want to sort an array of integers in ascending order, right? Ascending order means the smallest will come first and then the largest will be at the end, right? Now to divide the array into two parts, we're going to divide here the array into two parts. So I'm going to use a simple formula here that mid equal to start plus end. Start is nothing but to begin with, I have an entire array, right? So what is my range of an entire problem which I'm trying to solve is going to be the index 0 is going to be the starting point and the end part will be the last index of the array. So I have start and end here, right? To find mid, I'm going to simply make use of the formula start plus end by 2, right? So if I have 0 and 6, 0 plus 6 by 2 is going to give me 3 as my mid, right? Because 6 by 2 is 3. So this is where I have 3. So I'm going to divide this array into two parts. All right, because I'm doing the part of right now division. And remember, we are using divide and conquer. So I'm going to use the part of dividing the array, correct? So I'm going to divide this array, which is going to look like this: 38, 27, 43, and 3, right? The second part would be 9, 82, and 10. The whatever you see on the red, those numbers are nothing but indexes, right? Please remember the indexes are still going to be the same. Why? Because I am doing a logical division, right? I am not doing anything with the physical location of the elements which are present in the array. I am just saying, for my sake, my algorithm is just saying that I am dividing this main problem into small parts. Small parts means now the algorithm is going to say this is going to be my one start point. This is going to be my new end point. This is going to be a start point for this function call, and this is going to be end point for that function call, right? If you recall, we had seen a pseudo code for divide and conquer. Let's to go back here. If you see here, we had said, remember this, right? What are these? These are function calls, right? Basically, recursion has been used for divide and conquer, right? So when you divide this, right now we said we are going to divide it into two parts. Like we had a division from 0 to 3 and from 4 to the remaining, I think it was 6. This was the second part, right? So 0 to 3 is basically will be, again sent back for division further, and 4 to 6 will be again sent back for division further. But did I actually change the location of those elements? No, I have just done a logical division, correct? So moving on from that, so right now I've just done this division. Okay, now for this function call 0 and 3, what will be the middle value? You'll have 0 plus 3 divided by 2. So 3 by 2, I'm going to do your integer division. So if it's 3 by 2, I'm going to take a value as 1, because 2 into 1 is 2, right? So which is less than 3. So this is 1. That means now I'm going to divide this into two parts. This half is this problem gets divided into two parts, which are going to have 38 and 27, and the other one is going to be 43 and 3, right? What are the indices still? 0, 1, 2, 3, correct? Now again, let's complete this part of the problem, and then we can go to the other part, right? So here also we have, now this is where your start is going to point to, this is where your end is going to point to, right? Here we again have to divide, right? Can I divide it? Yes, because there are two elements. I can divide those two elements into one element, right, of each. So I can divide this. Why? Because 0 plus 1 by 2 is going to give you 0. So your basically mid is 0. So this you get 38 here, and you get 27 on this side, correct? Now in this part, your start is also pointing to 38, end is also pointing to 38. Your start is pointing to 27 and end is also pointing to 27. What are the indices here? Index 0, this is index 1. Tell me, after this step, when start and end is equal to the same index, or in other words, in this sub problem, I only have what? One element. When we have only one element, tell me, is it even possible to divide it further? No. What are you going to divide one element into, right? You cannot make it divide it into anything, correct? So that's why I'm going to stop my division step here. That is one reason for why am I stopping it. Second reason is if I have to think it in terms of recursion. Tell me, in recursion, we stop dividing, or in other words, we do not make any function call for base condition. The reason is because we know what the answer should be for that base condition. Am I right? So for example, here the problem which you're trying to solve is basically to sort the elements in your ascending order. In other words, whatever sub-problem you are having, you're trying to solve, so that's problem of sorting the elements for that sub-problem. Right now, you have a sub-problem which has only one element, and the problem you're trying to solve is to sort them in ascending order. Tell me, if you have one element, isn't that sub array, okay, or that sub problem already sorted? Yes. Can we this be a base condition? Yes. Do you need to do anything here? No. You can simply return from here and say that my sub problem, which is of size 1, is already sorted. So there are two reasons, right? Both of which are logical. One is you cannot divide a sub problem whenever that size is 1, right? Because there's nothing to divide. Second thing is, whenever you have a sub problem of size 1, it comes down to, can I sort that sub problem of size 1? Yes, because if you have an array or a sub array whose size is only 1, that means there's only one element present in that array. That array is already sorted in ascending order. So we're going to make use of this logic. So I'm stopping my dividing step here. Okay, now let's come on this side and completely divide the other parts of the array as well. So here, if you see, this is what your start should look like. This is what your end. I'm just using a short form, start and end. Now between 2 and 3, how do you find the mid? 2 plus 3 divided by 2. So 2 would be your mid value. Okay, so here I'm going to divide this. This is going to look like 43 and 3. Again, the index is going to be the same, which is index 2 and index 3. I have not changed any physical location of the elements present in the array, right? Because I have not done any swappings or anything. I'm just doing a logical division. Okay, now we are finished here, right? So now tell me, once you finish dividing the array and you have also solved the array, the solution, I mean, you've already solved the problem for that sub problem. In other words, when you have this sub problem which is of size 1, what is the solution? I mean, the element and the array is already, sorted. Okay, that means the sub array, okay, which is starting from 0 and ending at 0, is already sorted in ascending order. Similarly, the sub array, which is starting at 1 and ending at 1, is already sorted. Correct? If it is sorted, tell me what is the next step of our divide and conquer. Divide and conquer algorithm says keep on dividing until you cannot divide further. Once you have finished, dividing your sub problems and you have found the answers to the sub problem, now you have to take the solutions which you have obtained for the sub problems and combine them to get a solution for a bigger sub problem. That means here, if you see, please look at it very carefully. Let me use a color green. Okay, so when I'm trying to now do the job of combining, or in other words, the job of conquering, right? So now I'm combining the solutions for two sub-problems, right? So if I'm combining the solutions to two sub-problem, I'm going to get a sub-problem which is basically from 0 to 1, right? Because you're combining from 0 to 1, I'm going to get this. Now tell me, isn't this question very similar to having that you have two sorted subarrays, and the combining step is nothing but to combine these two sorted subarrays into one big subarray? Yes, and we know exactly how to solve that question, which can be done actually in a linear time complexity. Yes, so basically combining step here in merge sort is nothing but is you have two sorted subarrays, right? We have this sorted subarray. Our job is to combine them together into one sorted subarray. Correct? How would you do that? Now tell me, when you have two sorted subarrays, 38 and 27, if I have to combine them together, the answer would be 27 and 38. Yes, so tell me, what have you done? Using the solution for the subproblem which is at 0 and the subproblem which is at index number 1, we combined them and found the solution for a bigger subproblem which is from 0 to 1, and our job was done. Correct? Now when we got 27 to 38, okay, now tell me, after this, where should I go? Let me solve this, because I can even combine these two. These two can be now combined into, let's use the same colors here. 3 would be here, 43 would be here. This is your index number 2. This is your index number 3. Now tell me, we will come to know, if somebody has a doubt that why after this I went and combined this, you will understand this little shortly. It's basically due to recursion, but I'll explain them in just few minutes. Okay. Now tell me, we have these two solutions, right? Where is this? This is one sorted, this is one sorted. Again, what are we doing? We have one sorted subarray here, right? And we have another sorted subarray here. Now what we have to do? We have to combine these two into one big sorted subarray, which we know how to do, correct? So we're going to do that exactly. Let's say I'm going to combine this. This is going to give me a bigger array, which is going from 0, 1, 2, and 3. If I have to sort this, what we're going to get is 3, then it is going to be 27, 38, and 43. Correct? So I got a bigger subproduct, right? Now let's go back from where we started. This was your main array, which was it 38, 27, 43, 3, 9, 82, and 10. I divided my array into two parts here, correct? And then this first half which I had, I kept on dividing this until I couldn't further divide the array. Once I couldn't further divide the array, I used the concept of divide and conquer and started combining the solutions for the subproblems which I had received. Okay, so I have reached here, right? So I'm going to combine this and get an answer here. Now remember, divide and conquer actually uses the approach of recursion. It uses recursion to actually solve the problem. Tell me if it is recursion. Recursion is going to make sure to complete one part of the tree, right? The left hand part of your tree is going to be completed first. Once you have finished this part, all right, once you finish this, let's write a numbering for this. That will be easier to understand. Let's use a color. Let's say we use a blue color. The first step would be the division step. Okay, when you're dividing. Second step is I'm dividing here again into two parts. Then the third step is again dividing this 38 and 27 into 38 and 27. Now this is basically my sub problems which already have solutions. So my fourth step will be to combine them. Correct? After I combine them, tell me your job here is done. You are going to go back to the parent. The parent was here. Correct? Now tell me if you're finished here, what is it going to do? According to recursion, what they're going to do is you're going to come to this part, which is this subproblem, because we have just taken care of this part, right? This is the left part of this, but this was your main parent. The left part is taken care, meaning what? 38 and 27 has been sorted together into a subarray, right? This was your subarray, 38 and 27, which actually you divided this entire subarray from 0 to 3 into two subarrays. 0 to 1 and 2 to 3. What did we do? 0 and 1 is now sorted into 27 and 38. So now we are going back, and now what is our job? To complete sorting this 43 and 3. So that's what we are going to do here. So this is the fifth step. Yes, sixth step is you're going to basically, you basically have this sorted parts. You're going to combine them and you got what? 3 and 43. Now what do you have? You have two sorted subarrays, which is now 0 to 1 and 2 to 3. To make sure that this particular subarray from 0 to 3 is finished sorting. When can I say 0 to 3 has been completely, this subproblem 0 to 3 is completely solved? I can say it is completely solved when this 0 to 3 is completely sorted subarray, right? Right now what I have is from 0 to 1 which is sorted and 2 to 3 is sorted, correct? What is the last step? The last step would be to combine. This will be the step number 8, where I am going to combine these two sorted subarrays into a main, big subarray which is sorted from 0 to 3. Okay, that means when I finish the step number 8, what I've actually finished is sorting the array from 0 to 3. How many steps did I take? 8 steps to complete this. Is this understood? If not, might be you can pause it here and rewind the video and check what all steps happened here. Okay, fine. When this is done, let's continue. Now what you're going to do, if you have finished sorted your this part, where you're going to go now? You came from here. That means now we have to finish sorting this sub array as well. Once we finish completing, sorting this sub array from 4 to 6, we are going to get one sub array which is sorted from 4 to 6, another sub array which is from 0 to 3. That will be combined and give us the answer for the entire array, right? So let's start here. Let's first, divide this and combine. So let's take a different color for division. So from this is your start and this is your end. So between 4 and 6 you have 10 by 2. So mid is basically 5. So I'm going to divide in this fashion, right? So I'm going to have here, let me take it here, 9 and 82, right? And 10 will be here. Now 9 and 82 will have indexes as 4, 5 and 6. This is your start here, this is your end here, this is your start, this is your end. I cannot divide this any way further because there is only one element, right? But I can divide further this. So I'm going to divide this into basically 9 and 82, which is 4 and 5, correct? Once I finish this, what I can do is I can combine. So let's use the green color which we were using to combine this. This will be combined into these values. There'll be 9 here, there'll be 82 here. This will be index 4, this will be index 5. This we have index number 6. Now I have to combine these two to give me a value. Let me use a green color only just to be consistent. So I'm going to have here, what are the values? The values are going to be 9, then 10 and 82 for 4, 5 and 6, right? Let's just number them because we were just numbering everything. So after 8 step, what you're going to do is you're going to do the 9th step of dividing this 9, 82 and 10 into 2 parts. 10th step will be to divide this 9 and 82 into 2 parts. Then the step of combination, right? Because we only have a sub problem with one element, so you cannot divide further. Now you have to start the job of combining, right? From 11, what are you going to do is you're going to come here, which is step number 12. There's nothing to divide here because there's only one element present in the sub problem. Now 11 and 12 step is done. Then we can have what? When you go back to this, now our job is to basically sort this entire subarray. We can do this by using the divide and conquer approach. We have two solutions to sub problem. We are going to combine them together in a step number 13. Okay, so now by step number 13, you have basically two sub arrays, okay, which are completely sorted. In other words, we have found the solutions for the two main sub problems, which is from 0 to 3 and from 4 to 6. Now by using recursion or by using divide and conquer, whichever way you feel comfortable in, I need to basically combine this and get my answer to the main problem, which was from 0 to 6. All the elements from 0 to 6 needs to be sorted. Now you can simply do, because you have two, because you have this two elements, two sub arrays which are already sorted, I can now simply create one main sorted sub array, right? Now you already know how to sort, two sorted sub arrays into one main sub array, right? So I'm going to have 3 and then it's going to be, I think, 9 and then 10, 27, 38, 43 and I think 82. I hope I did not miss anything. So we'll have 0, 1, 2, 3, 4, 5 and 6. So this is my main array which has been sorted. In how many steps? Let's say this is the step number 14. In 14 steps, I was able to go from an array which was not sorted to an array which was completely sorted. How have I done this? Let's quickly recap. What I have done is use the concept of divide and conquer. I had a problem which had how many elements? 7 elements. Starting with index number 0, 0 to 6, that many elements were added. I kept on dividing it into sub-problems. Okay, so in the first step, I divided into two sub-problems. I first said, let me first solve the problem of 0 to 3. Solving the sub-problem means here I have to sort this half of 0 to 3. To sort this 0 to 3, this itself is a bigger, it's not a very small sub-problem, it's a bigger sub-problem. So I'm going to keep on dividing my sub-problem until I cannot further divide the sub-problems. Once I cannot divide the sub-problem, technically I'm actually hitting the base condition of recursion. If you have only one element in your sub-problem, that element or that sub-array is already sorted in ascending order. Making use of this concept, if I'm going to combine the solutions of two sub-problems, okay, into one, correct? So here I had sub-problems of size 1. They are going to combine together to make a sub-problem which is of size 2, correct? That means I have now solved a sub-problem from 0 to 1 by combining them and getting a sorted sub-array from 0 to 1, correct? Same thing I'm going to do for 2 to 3. I will get here a sorted sub-problem from 2 to 3. Now I need to combine this so that I get a bigger sub-problem 0 to 3 which is sorted, right? That means I have solved the question for 0 to 3. Same thing will be replicated for 4 to 6. Once I have solution for 4 to 6, that means once I have sorted the sub-problem from 4 to 6, I can make use of the sub-problem solution from 0 to 3, another sub-problem solutions from 4 to 6, right? Combine them, right, using the concept of divide and conquer, and get the solution for the main sub-problem which was of size n. Okay, I hope you understand this. Just make sure to rewind the video and see wherever you have any doubts. All right. So if you have understood this, now we'll go, the next part will be to writing the code. Whatever we have done here, same thing will be there in the code. In fact, when you look at the code, you can see this, right? Divide and conquer, the pseudo code, your code is going to look very similar to this. Very, very similar, right? Here also for the merge sort, you're going to divide it, going to write a, so look at this. If I, let's take a different color here. See, what is this mid going to look at? The mid function. In our case, mid is going to simply look at like this, start plus end by 2. Yes. What is this divide and conquer AI mid? We are going to simply call it's a recursive call. This is also going to be a recursive call, right? What is the combination step here? In our case, when you're doing merge sort, our combination is nothing but what? Our combination is nothing but the code to sort, okay, two already sorted array elements, or two already sorted sub arrays need to be sorted and merged into one big array. That is our basically combination step, right? And there is one thing here, which is the if condition, which is a stopping condition. Tell me what will be our stopping condition? Our stopping condition will be until you have more than what? One element present in the subarray, you can keep on dividing. What will be a stopping condition? If you have more than one element present in the subarray, you have to keep on dividing. Let's understand this. If you can look, just take an example of 38 and 27, right? So your 38 and 27 had indexes 0 and 1. If I made a choice of dividing this, this is basically your start and this is basically your end, right? Once you divide this, this is 38, this is your start and this is also your end, which is index number 0. For index number 1, this will be your start, right? And this will be your end. You made a choice of dividing only when start is less than end. Do you agree? Take any subproblem, okay? If the size of the subproblem is 2 or more, you're going to divide, correct? And that subproblem, which is of size 2 or more, is always going to, fulfill this condition that start index is less than end index. Why not equal to? Look at this. Whenever start index is equal to end index, that means you have only one element present in your subproblem, right? And that's when you do not want to divide. So if it is more than, one size of the subproblem, you're going to write the code of dividing and combining. But if it is not the case, you're not going to divide, simply return the array. I hope this is clear. Now let's go to the code and write the code for merge sort.